Hello, my name is Andrew Shields. I'm the Mathematics Coordinator for the Classical Academies. Thanks for taking the time to watch this and invest in your students' mathematics education. Let's take a look at two math problems, one from middle school and one from high school. These are typical problems. You can find examples of problems like these in your students' math homework pretty much any day. Now, the subtitle of this talk is Math Your Phone Can't Do. But these are both actually examples of math that your phone can do. So I would encourage you actually just go ahead right now and pause the video and ask Google or Siri the 8th grade question. Just ask it aloud. What is the volume of a cylinder with a radius of 5 centimeters and a height of 8 centimeters? For the math for one, you'll probably actually have to type that in because, at least for Google, it doesn't quite hear the audio correctly on that one, too much going on. But if you just type it, you should find that your phone can actually do that. So I'll let you pause and then come back once you see that, yes, my phone can actually do that. So here are two screenshots from my phone doing those two problems. And to me, that's pretty cool. I didn't have to do anything special. I didn't have to know anything. I could just do that. Now that's cool, but also as an educator, specifically a math educator, that's a little bit scary. So let's talk about that classic math question, the favorite question of math teachers and frustrated parents at home. We just love it when our students ask us, when am I ever going to need this? And for many of us, when we were in school, the answer to that question was, well, when are you going to be walking around with a calculator in your pocket? Well, always. So if we have these incredibly powerful calculators, and obviously they can do more than just calculate, but they are incredibly powerful calculators. If we have these in our pockets, if we have these with us wherever we go, the question becomes, do our students still need to learn math? Or not? And so my answer, of course, is yes. And my answer is yes, not just because if the answer was no, if students didn't need to learn math anymore, I wouldn't have a job. My answer is yes, because first of all, we've been through this before, and we'll get to that part of the talk in a minute. But my answer is also yes, because the math that students should be doing in math class, what actually should be happening in math class, should go way beyond just computing volumes and sketching graphs. And I'll emphasize that it should go way beyond computing volumes and sketching graphs. And let's get into that. So we still need to learn math. We have these calculators, these amazing devices in our pockets with us at all times. So what is actually the purpose of school mathematics? What is it that we should be learning? And the National Council of Teachers of Mathematics, the NCTM, which is kind of like the big organization nationally for math educators, lays out 4 primary purposes for math education. And I think that a lot of students, parents, and teachers focus primarily, if not exclusively, on the first one, to expand professional opportunity. And that's not bad that we focus on that. That is one of the purposes. But let's dive a little bit deeper into both how we currently focus on that and what really it should mean for us and our students. So this lines up really nicely with that question we already brought up, which is, when am I ever going to use this? When am I ever going to need this? And so I think usually what we see is sort of a progression here, kind of spiraling or staircase progression here. Our high school teachers answer that question, well, you're going to need to know this to get into college, or you're going to need to know this to get a good job. Our middle school teachers then, of course, say, well, you'll need this in high school. And our elementary school teachers will, of course, tell their students that they will need to know this, whatever this happens to be that they're learning that day, when they get to middle school. And then everybody's favorite, of course, you need to know this because it's on the test. Now, aside from the last one, that type of thinking is not inherently wrong. That is how math works. It builds upon itself. And the ultimate goal is to go to a good college, to get a good job, both of those things, one or the other, both, hopefully. So that's a good thing, but let's go a little bit deeper here. First of all, I love the way that the NCTM has worded this: expand professional opportunity. Math education, and really education in general, is all about keeping doors open, making the right choices so that doors will stay open to you as a student when you progress through both your education and then later your professional, your work life. We don't want to make those types of choices that close doors early for us or make it more difficult for us to get where we want to be going in the long run. And so, of course, we have a lot of students who are already interested in a STEM major or a STEM career. STEM, of course, meaning science, technology, engineering, or mathematics. And so for most of these students, they say, I want to be an engineer, I want to be a scientist, I want to be a mathematician. They already typically understand that path, that they're going to have to take a lot of math classes and do well in those math classes. And so, of course, we want to encourage that. We want to provide appropriate outlets, appropriate avenues for the students to go through to get to where they want to be going. But of course, that's not everybody. Some of our students are unsure what they want to do, so they're not as gung-ho about what math classes they're going to take. And then, of course, there's the students who are interested in not a STEM major or career. So these students are, they say, no, math's not for me. I'm not a math person, and we'll get more into that language a little bit later. But for those students, either the ones who are unsure or the ones who really don't think they want to do something STEM related, I think, one, it's important that we just are open about, the idea of keeping doors open. Don't choose a path that right now is going to close doors for you, that's going to limit your opportunities. We want to expand your opportunities. But it's also important to think about, well, what might you be interested in, and how might math help you down that road? For me, I think about just the fact that data and computing have become really just pervasive in so many parts of our society, so many careers today. To name a couple, sociology, psychology, business, marketing, finance, journalism, linguistics, graphic design, gallery or theater major or manager. All of these are really data and computing intensive careers that maybe people wouldn't naturally associate with STEM. Someone who's not necessarily a STEM person, and again, we'll talk about that language, they might not realize how useful math will be in those careers if that's what they're interested in. When I was a kid, I was pretty sure I was going to play in the NBA or be an astronaut, maybe both. But those plans changed, and when I look back, I'm just glad that I had people in my life that encouraged me to stay on that path that would keep those doors open for me. Not the doors to the NBA or astronaut. I did not choose, I did not make choices that kept those doors open for me. But people helped me make the right choices that would keep enough doors open for me that I'd be able to enjoy a really satisfying professional life that I've made for myself so far. So, I think that's something that we need to encourage students to keep in mind, that we want to keep those doors open. While also helping students see the math that really can be involved in some of the careers that they might not immediately recognize. So when we go through this progression, again, this progression of you're going to need this, you're in third grade now, what you're learning now in third grade is going to be important in fourth grade, what you're learning in fourth grade is going to be important in fifth grade, and so on. That's all true, but let's make sure that we bring that bigger picture into the conversation explicitly for students. We can bring in problems, we can bring in resources that help students see how math can be useful in some of these other careers. And be open about opening doors. Be clear about that for students. All right, so that's our first one. Expand professional opportunity. So the next of our 4 purposes for school mathematics is to develop deep mathematical understanding. And so again, we've got calculators in our pockets at all times. We understand that, expanding professional opportunity, but it's really important that we help students develop a deep understanding of the math that they're doing. It's not just about, okay, you're going to need this in third grade, so you just got to be able to master this. And then you're in fourth grade, now you're going to need this in fifth grade, so you just got to be able to do this thing. It's so important, that we don't just view it as checkbox, I can add, check the box, I can multiply, check the box, I can graph a line. We want to think about developing that deeper understanding, because that's going to create a stronger foundation. It's just going to make taking those next steps so much easier for our students. So let's look at 2 more math problems. So to start, we've got 4th grade multiplication problem. And here's sort of what we'd consider the standard algorithm approach to multiplication. You multiply the 7, you put the little 2 up there, you bring things down, you add, and wow, you get the right answer. And there's nothing wrong with this. It's called the standard algorithm for a reason. It didn't become the standard algorithm because it's not good. It became the standard algorithm because it works, it's efficient, it's concise, it's elegant. But memorizing this algorithm by itself doesn't help students develop deep understanding, and that's a big issue. So as we look at this, our students really understanding what's the deal with that little 2 up top? What's the deal with that 0 in the bottom right there? What's going on with those 2 numbers? And it's important that students understand what's happening there. Why do we put that 0 there? Some people don't even put the 0 there. They just shift everything over. Now, really what's happening? So there's other ways that we can have students do these problems that will really encourage them to develop that deeper understanding, which will help them go through that progression from grade to grade to grade to career or college or both. And so I want to look at just, really the same exact math, but just written out in a different way. And so what we're able to see when a student does the math in a way that, similar to what's on the screen here, it just makes it a little bit more manageable for students. It makes it a little more understandable. Now, for those of us who've mastered the standard algorithm, we look at this and we're like, wait, that's like crazy. You've written so much more. There's way more stuff. Again, the standard algorithm is the standard algorithm for a reason. It's neat, it's clear, it's concise, it's efficient, it's effective. But when we're first starting, if we want to develop long-term understanding, just going right to the fastest way to do something is not always the best approach. So what we're encouraging students to do here is to think flexibly about their numbers. How can you work with 17? How can you work with 23? How can you break those apart into more manageable chunks that you're able to really understand what's going on? Also, you might do this a different way than the person next to you, and that's great. That encourages discussion, that allows for justification, and actually it explains those 2 pieces of the standard algorithm, that little 2 and that 0. Well, I can see where they are. The 0 is there because we're multiplying by a 10 and not a 1 when I do that part of the problem. The 2 goes in that place because it's really 7 times 3 is 21. So I have 2 extra 10s to account for when I add them up in the end. And I'm not here to give you a multiplication lesson. I'm just using this as one example of how we can encourage a deeper understanding rather than just going right to the fastest way to do it, maybe the way that you remember how to do it. But there's things that we can change along the way that's going to help students as they go through. Just another look at that. We can have students draw a picture of this problem using what we would call the area or array model for multiplication, where you can actually see what multiplication is. Multiplication is just how many squares do you have if you were to make a rectangle here, where one side was 17 units long and the other side was 23 units long. Break it into chunks that are easy for you to work with. Then you can count those squares more efficiently, more effectively. So using pictures, using different ways for students to break down the numbers at those earlier grades is going to be super helpful for them, because again, it's encouraging them to think flexibly, to make sense of the problem, to reason, to compare their solution with somebody else's. And that's just going to be so helpful as we go through that progression from early math all the way through high school, through college and career. Let's look at the same problem another way. And as I say that, maybe some of you are thinking, oh man, this guy's got his slides messed up. This is not the same problem. This is a different problem. But what I want to bring out is that no, these are actually the same problem. And this is sort of my point. When we encourage students to develop that deeper understanding at the younger grades, if they're flexible with their numbers, then when we get to letters in our math, which makes some of us feel a little bit uneasy, we see it as the same problem. We want to be able to see these two things as the same problem. When I write it out, when I do the algebra, it looks very similar to how we did the math in the previous problem. Let's look at it side by side. There's how we could encourage a student to break down the 17 and 23, multiply smaller chunks that make sense for them, put it back together. That's actually exactly how the algebra works there, doing the distributive property. And so when we encourage students to think flexibly, to develop that deeper understanding in the earlier grades, when they get to the algebraic thinking, it's nothing new. It's like, okay, I understand the idea of what a variable is and why I might want that. Now I can work with that because I recognize that I work with it in the exact same way as I work with numbers. We can even draw the picture for this algebra problem, really similar to how we drew the picture of the numbers. In this case, we don't have the squares because, well, we don't know what x is, so it wouldn't really make any sense to have a finite number of squares there. Maybe we're getting a little too deep into the math. But the idea, again, is that if we develop the deep understanding at an earlier age, that will help students along the way. Math is interconnected, it's rational, it's logical. All students can do it if we give them the opportunity and we actually require them to develop that deep understanding. Some people, when I'm talking, you're thinking, oh, you know what? Those different ways to do it, those are great. But my son, my daughter, they get it really fast the other way. So I don't need to do this stuff. Well, that's actually not true. We want to encourage everybody to develop that deep understanding so that when they move to the next step, they have that strong foundation for that. And they're also developing those logical reasoning skills. And then some people have the opposite reaction. Well, my student really struggles with math, so I need to just strip away all these pictures and all this explaining and all this stuff. I just need to show them the steps that they can then replicate. Well, that's again, that's the opposite of what we want. We need all students, high students, low students, middle students. We need them all to develop that deep understanding of what's going on. That's the purpose of math, and it will help them as they go through that progression. It will help them to see math as logical, interconnected, rational, something that makes sense to them. Now, I do want to bring something up because sometimes, again, how people hear what I've just said is that, oh, well, we shouldn't do the standard algorithm. That's not right. It's not what I said. And the way that NCTM says this is that you build procedural fluency from conceptual understanding, meaning before I teach the standard algorithm, the fast, quick, procedural way to do it, first I let students play with the numbers. I let them draw pictures. I encourage them to make sense of it. And then when they've demonstrated that they really do understand what's happening, now we can clean that up. We can make it more compact. We can make it more efficient. Because yes, this deep understanding is going to help your student when they get to more advanced problems. But if we're in, junior year math 3 and we're solving systems of 3 variables with 3 equations, and every time you have to multiply 2 numbers together, you've got to draw a picture, you're going to be here all day. So we have to get to that procedural fluency. We have to, but we don't want to jump right to that and strip away the understanding. That's going to hurt your students' ability to go farther in mathematics. And again, this is for all students. Okay. So our 4 purposes of mathematics. Hopefully we see that connection between the first 2, expanding that professional opportunity by going through that progression, keeping doors open, and developing that deep understanding at every step along the way is going to help that happen for your students. And that has to be built on understanding, reasoning, visualization, sense making. And it's through the process of investing in that understanding, that reasoning, that visualization, that sense making, that we provide students the opportunity to experience the joy, beauty, and wonder of mathematics. Again, I'll assume what some of you are thinking, and you're going to say, well, joy, beauty, wonder, that's not really a good description of the math classes I sat through. And you're probably right. But let's flip that question just a little bit. Is that a good description of the math classes that your students are sitting through? Is that a good description of the math that your students are doing at your kitchen table? Would you like it to be? I think for most of us, the answer to that last question, would you like it to be, is yes. I would like my students to experience wonder, joy, beauty in their schoolwork and be excited about it, to be enthusiastic about it, to feel that sense of accomplishment. So that's the third purpose of school mathematics, is to sort of just experience math as a human endeavor, as a human accomplishment, similar to the way students take art and music. It's something to be appreciated, and that feeling can be cultivated through mathematics. Let's look at a couple people who have said this better than I can. Mathematics is the most beautiful and most powerful creation of the human spirit. Mathematics has beauty and romance. It's not a boring place to be, the mathematical world. It's an extraordinary place. It's worth spending time there. The working mathematician can be likened to an explorer who sets out to discover the world. One discovers basic facts from experience. And there are two versions of math in the lives of many Americans: the strange and boring subject that they encountered in classrooms, and an interesting set of ideas that is the math of the world and is curiously different and surprisingly engaging. Our task is to introduce this second version to today's students, get them excited about math, and prepare them for the future. And I really like Dr. Bowler's quote there, the last one, where she really lays out our task for us. She's explicit about that. And the way I like to think about that is, if we take some of the words that for me jump out over those last couple quotes, in order for students to experience the attributes of math on the right side, the beauty, the joy, the wonder, the power, the romance, the extraordinary, we as parents and educators have to provide opportunities for and encourage our students to do the things on the left. We have to give them ways to engage, to explore, to discover, to create. Rote memorization of discrete skills and procedures doesn't promote those things. It does not lead to students experiencing beauty, joy, power, wonder, romance, or the extraordinary nature of mathematics. So it's up to us as parents and educators to recognize this as a purpose of mathematics and how that fits in with the first two, because again, for many of us, it's really just the first purpose that we focus on, expanding those professional opportunities. We got to get through it to get a good job, to get into a good school. But that purpose, expanding professional opportunity, is made easier by developing deep understanding. Developing that deep understanding is made easier by providing students the opportunity to really engage with the mathematics, to discover, to explore, to create when they're doing math. And that will naturally lead to students experiencing beauty, joy, wonder, power, romance, and the extraordinary nature of mathematics. And now that takes us to our fourth purpose, understand and critique the world. We live in a complex and fast-moving society. Learning mathematics not only gives students the concrete skills to understand the data, the graphs, the equations, but it promotes logical thinking, rational habits of mind that will allow students to sift through all the stuff that they hear from the media and politicians and different social, commercial, scientific systems. The goal for me of education at large, the goal of this discussion is to talk about the purpose of math education, but at large, the whole education system, to me, the goal is to produce competent, productive citizens of our democratic society. And we have to explicitly engage students in the habits of mind, the logical reasoning, the sense-making, the development of deep understanding to help them along this path. To throw another quote at you, here's George Washington on the matter. Mr. Washington says, "The science of figures, to a certain degree, is not only indispensably requisite in every walk of civilized life, but investigation of mathematical truths accustoms the mind to method and correctness in reasoning, and is an employment particularly worthy of a rational being." So what I think President Washington is saying here is that the importance of mathematics is based on both the direct importance of understanding the computations and calculations of modern society, but also developing the habits of mind required to reason with and process through the claims and arguments encountered in a modern society. And this is George Washington. That's over 200 years ago that he's saying this. So how much more is this important for our students today when we're thinking about the society that we live in and all those issues that I listed and so many more. So I really believe that this fourth purpose, to understand and critique the world around us, for students to really actively be able to engage in society, mathematics is just a huge part of that, both explicitly with the actual calculation, the ability to understand the equations, graphs, scientific statements, but also just that the habits of mind, the reasoning, the developing of a deep understanding when you learn something that's so crucial for our students. So we've got our four purposes. So now, what can we actually do about that? How can we as parents and educators help our students meet those four purposes? And so I think the first thing that we can do is to evaluate what our students' mathematics experience looks like. Are there opportunities within the curriculum, within the work that my student is already doing, to help my student meet those four purposes? And so I feel like there's just this, ask yourself a couple questions, reflect. Which of the four purposes do you think your student is doing so far? Where are you lacking? What can you do to change that? And I think so often when we go through the math, we want to think about, okay, well, just what do we need to know? How can we get through that? What do I have to be able to do to check this box to move on to the next lesson? And so for many of us, we pine for the math we grew up with. We just want to get rid of all this Common Core fluff. Or maybe we know we should be doing it differently, but it's been a long homeschool day. You've got a Zoom call to get ready for because you can't go into the office anymore and school's closed and all this stuff. And you just want your students to solve the equation and be done with it. But as much as you can, and I know it's hard, I would encourage you to stop and think about what's already happening on that math worksheet or that math textbook or whatever your student's being asked to do that would allow your student to meet these four purposes, and really emphasize those parts. How often do we rush through and we're like, that's an application problem. That's a word problem. Don't worry about that one for today. As long as you can solve the equation, you'll be all right. No, that's not where we want to be. So some simple things that you can do to enhance your students' mathematics experience is just ask them a couple questions. Ask them, how did you think about that? How did you get there? What's going on in your head? And how did you think about that is a really important way to say that. Because if we say what I just said, which is how did you get that, what that will produce is just, well, I followed the steps. Well, how did you think about it? How does this make sense to you? Or if your student is stuck, well, let's try to think about it another way. Can we draw a picture? Can we look at a different problem? What can we do to get through this? And just those two simple questions over and over are really important. How did you think about that? And can we think about it a different way? And those can both be done whether the student is right or wrong the first time through. And please, 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 please remember how detrimental statements like these can be. We don't talk about math people and not math people. All students can achieve high levels of math learning. We all have our strengths and weaknesses, no doubt. As I said before, I'm not in the NBA. But we're not necessarily asking you to model, to be a math professor, to be a mathematician. What we're asking you to model is curiosity, perseverance, and sense making. So when you say things like, oh, I was never a math person either, that erodes that confidence, that trust in the fact that everybody can do this and that it should make sense to me. Um, so we want to eliminate some of that language. Let's just take a quick look at our problems from earlier. If we take that simple graphing problem and just add some context, allow the students to do some of the discovery on their own, then that opens up a whole world. Well, the students are coming up with their own data. They're not making it up, but they're finding it themselves. So why did you pick this year? Why did you do several years? Why, how does this connect to history and the development of a calendar and the understanding of seasons and agriculture? How is this all connected to think about the world around you? Bring in climate change if you want to. Don't bring in climate change if that's too much for you. But there's connections that we can make, and there's sense making, and there's exploration that can be brought into here. And I think also just the more that we connect something like this to the real world, to finding data, the more students see this as applicable. If we're just graphing things by themselves, yes, that's good. You have to have that skill. But, mathematical modeling is an incredibly important skill. Model the economy, model the flight of a rocket, model the spread of a virus. Helping students see this as an important part of understanding the world is crucial. And sometimes it's just as simple as, again, like I was saying before, how did you think about that? Ask the student to explain why the formula makes sense to them that they're being asked to use. Ask them to compare it to a different formula. That type of sense making, rather than just regurgitation, is what we want to really push for here. So I want to bring us back to the beginning, when we talk with the subtitle again, Math Your Phone Can't Do. And one of the things that I said was, we've been through transitions like this before, where we have technology that's really just changing what students need to be able to do. A couple of visuals for us there. So we've got an abacus, a slide rule, an adding machine, a digital calculator, and a graphing calculator. All of these things changed what math students needed to be able to do. Not that long ago, some of you may actually remember, in high school, students had to memorize log tables and square root tables because they didn't have an efficient piece of technology to do that for them. So they just had to memorize it. We don't do that anymore. So as technology advances, it continues to shape and change our society. So if the goal of school is to produce students that are able to be productive, contributing members of society, then it just makes sense that the education system must change with it. Longing for the old way, wanting math to be simpler, to just do the problem and move on, wanting to get rid of the pictures and the sense making and the understanding and the word problems. It's really just wanting your students to be prepared for a world that existed 30 or 50 or more years ago. And we want students to be prepared for the world that they're going to inherit. So that's our goal. One of my favorite examples of this, as a math person, one of my favorite movies is Hidden Figures. And I love how this technology changing what we need to know, changing the skills that we have to be successful is portrayed in the movie, where Dorothy Vaughan, who's portrayed by Octavia Spencer, has to learn the math to avoid being replaced. She worked as a human computer, somebody who computed all the numbers because they didn't have machines that could do it fast enough. They didn't have what we would consider computers today. And so she learned how to do the math that was required to operate the new technology to continue to expand her professional opportunities. So we as parents and educators, we have to adapt, or our students, our sons and daughters, will have limited professional opportunity. We have to adapt, or our students will live in a world they don't fully understand, a world which they're incapable of making informed decisions when presented with choices that will shape the future of our country, the future of our world. We have to adapt in order to promote deep understanding, wonder, and joy. we have to adapt to avoid math anxiety and math aversion. It's our choice. What are the math experiences that we provide for our students? Do we provide experiences that develop deep understanding, that allow our students to expand their professional opportunities, that allow them to experience wonder and joy and to critique the world around them? Or do we provide experiences that make math frustrating and seem like a rote memorization set of discrete skills that's just static and frustrating? That's up to us as parents and educators. And so when you think about your students' math experience in the classroom and at home, always be thinking about these four purposes of mathematics, all four of them, not just the first one. At the Classical Academies, it's my job as math coordinator to support and push our teachers and our curriculum in the right direction to ensure that our students are being provided with mathematics experiences that meet all four purposes that prepare our students for citizenship in the 21st century. Um, and what I'm asking you as our parent educators is that you make that same push. Provide your students with the support they need to fully experience all four purposes of school mathematics. Thank you for taking the time to watch this. Hopefully you made it all the way to the end. I know how that goes with videos. Sometimes you start and don't quite make it. So for those of you who made it to the end, I appreciate your time. Please feel free to reach out to me if you have any questions or concerns. I would love to have you recommend this session to your friends. I'm not just trying to get my views and likes up, but part of my job is to get this message out to all of our families so that we can embrace um, the changes that we need to make sure that our students are learning the mathematics that they need to be learning. Thank you very much.